Alright, hello everyone. This is the solution for day 24 of Advent of Code. And today is all about intersecting lines. So our input today will be given lines like this. So it tells us the initial position and the velocity of hailstones. And for the first part, we want to consider the trajectory of those hailstones. And for that, at least the x and the y coordinate. And then we want to know whether those trajectories intersect for different hailstones, and if they intersect within some given box of coordinates. Okay, so how can we do it in code? So we represent array as initial point and the direction, and then it will be important to intersect two rays. So in order to do that, we can use a formula that tells us we can calculate this value of d of this term divided by this term, and then the intersection of two lines will be given as the initial point plus d times the direction vector. So now the rays, since we have rays which have one endpoint and in the other direction go until infinity, the particular intersection point only lies within those rays if both t and similar value of u are non-negative. So that's how we calculate intersection of rays. We essentially calculate values to intersect the two corresponding lines, and then we check if the denominator is 0, which tells us the line are parallels, then we have no intersection. And then we also check if both of these values are non-negative. That means they actually not just the lines intersect, but also the rays, and then we return the intersection point. Okay, and that allows us to solve the problem. So of course we need to parse the lines. In this case, we just ignore the C character, and then we can solve the problem by parsing all the lines to get this rays, and then iterating through all the pairs of rays, calculating the intersection, and then checking if the intersection is not none, and both the coordinates of the intersection are within S and T. Then we're supposed to add 1 to our solution, so we count the number of occurrences when this happens. And this will allow us to get the correct solution for part 1. So we should, of course, test. So first, we test this intersect rays function, because we want to know that we did not make a typo or something like that. And that looks good. So we also run the test on the solution on our test input, and that also looks good. So we can also run it on a real input, and it also turns out it gives us the correct solution. For part 2, we actually have to consider the x, y, and z coordinate, and then we want to throw a rock, and we're supposed to hit all of those rays with one throw, all of those hailstones. So for that, it's a very overdetermined system, so we want to know essentially 6 values, so the initial x, y, z coordinate of the stone, as well as the direction vector. Another 3 values for the direction vector. And when we have a lot of hailstones, we know that we need to cross them. So also the coordinates of those hailstones are fairly large, so that kind of makes the problem a bit complicated to solve. So one could use some kind of pre-implemented solver for this. I chose a slightly different approach. So what I did was first use some gradient descent to get some approximate solution. And then, since the numbers are fairly large and have a lot of digits, that is not good enough to get us an exact enough solution to actually figure out the solution. So then, but however, for this position or direction vector, which has 3 values, the x, the y, and the z, the numbers are much smaller. So I hope that actually those 3 values are integers. And since they're much smaller, rounding our approximate solution actually gives us the exact integer values. And then based on those integer values for the x, the y, and the z, I did another function, essentially reused the function from part 1 to get the exact x, y, and z coordinate. So first, to get the approximate solution, I used some gradient descent, where in this case, by hand implemented the loss functioner, and then by hand implemented the updates. And if you run that for long enough, it gives us a fairly good approximation. So that we can approximate the x, the y, and the z fairly well, but not x, y, and z. And then the second part, where we want to get the exact x, y, and z coordinate, by assuming we already have the direction, I essentially use this intersect rays function from part 1. All right, I don't go into the details, but the code will be on GitHub. And yes, we can of course run this on the test input, and that looks good. So we can also run it on the real input. And at least for me, we do see that the x, the y, and the z are fairly small, whereas the x, y, and z are much, much larger. So we actually need to be a bit more precise at getting them exactly right. Yes, that's it for today's puzzle. Hope you enjoyed 24 day of Advent of Code and had some happy holidays. Best of the luck for the rest of the year at the very last day, and see you around.